to your lecture session, okay, rather than lab session. That's one more point. Okay, so the thing is that we have program for timer. We know how to program timer in mode 0, mode 1 and mode 2. We know how to program that thing. But what we are doing right now, okay, if you closely look at this program, or let's say if I'm closely looking at this step, okay. So what we are basically doing here, I'm setting up my timer here. I'm running my timer here. I'm checking whether overflow is there or not, and then whatever task has to be done after some delay, I'm doing that task, and then I'm again going back to check the timer. That means what I'm doing when I'm using timer is I'm wasting my time. Okay? What I am doing is I'm wasting my time. How I'm wasting my time? Okay, so let's see what we are doing in case of our timer. So right now, what we are doing, we have this. Let's say I have this program. Okay, inside while one, what I have written is while tf0 equals 0, then led does not equals led, and then some other task might be there. But what basically I'm doing here is while I'm doing this, while I'm checking for the TF0 overflow flag, during that time, what I'm doing is I'm constantly looking at this timer overflow flag. Okay, I'll give you a real-time example. Like for an example, if your friend asks you something like, yeah, you ask your friend, like, please send me this and this so and so documents, okay? And he is sending that document, but you don't know when, which at exact which moment your document will be received. So what you are doing is you are just waiting for his mail or his WhatsApp or whatever he's going to do by looking at the phone screen. Is it a good thing? I need some responses. Okay, what I'm doing is I'm just constantly staring at my mailbox that my friend is going to send me a document. He has told me that he'll send document in 5-10 minutes. So I'm waiting for his mail by looking at my mailbox. Is it good thing to do? I need some responses. See, the thing is, if you do not respond, I'll not go ahead. I'll stop here and I'll leave the class, even though I'll ask the question in the exam paper. So please be responsive. And I expect the respondent to be like different response, and the response should be there. So every time there you have Manish and the 2-3 people will answer. So let's go with Yagnesh. Please answer me. Is it good thing to do? I'm repeating one more time. I'm repeating one more time. Okay. Yagnesh, let's say Prithviraj is your friend. Okay. So Prithviraj is going to send you a document. You have asked Prithviraj, send me book for EE246. મને microprocessor ની book જોઈએ છે. You have asked him that. And now Prithviraj told you that I'll sending it in 5-10 minutes. Okay, please wait. I'm sending it right away. Okay. So Yagnesh, would you like constantly staring at your mobile phone, like particularly at your mailbox? Would you be like constantly monitoring your mailbox and looking at it, whether I have received a document or not, or you do something else? Yes, Yagnesh, go ahead.
Sir, notification.
Correct. I want that answer only. Okay, so what you will be doing is basically you will be waiting for a notification rather than constantly staring at your screen. That means constantly checking for that same mail is a dumb task. That's the first point. And you have some other features that can do it for you. So we are also doing that dumb task here. Okay, how I'm doing that dumb task? I'm constantly waiting for my TF overflow flag, timer overflow flag to set. Okay, I'm constantly waiting by executing this instruction. Okay, what this instruction will do? This instruction will check what is the status of TF0 flag. If it is 0, what it will do? It will go inside the loop. Okay, but loop is blank. So where it will go? It will come again here. Again it will check. Again it will go inside loop again. So I'm constantly waiting for timer overflow flag to set. I'm not doing even a single task inside my while run. Okay. So what I'm doing here is I'm waiting. Okay. Without any second thoughts, I'm waiting for my timer overflow flag to set, and that's not how things work in real world. Okay. So in mobile, what do you have is you have an option for notification. So you have to basically set it up. Okay, you require to set up this notification. Then what will happen? Even if he reply you after 1 hour, then also he will be notified. Even if he reply after like 5 minutes, then also he will be notified. So like he reply at any time, or he send the document at any point of time, you will be notified. So what you can do meanwhile, you can do your own other things. Okay, like I can be watching a TV, and when notification pop-ups, I know like I have received the document. So meanwhile, you can do some other, maybe it may be a productive task, it may be a non-productive, but it depends. But you can basically do some other task rather than waiting on your phone screen to receive that document. Okay, that means you are free to do other tasks, and you will be notified whenever you have that document. So same feature can be like same way you can set up your timer in such a way that whenever your time delay completes, at that time you will be notified. You can do that. So rather than waiting like this, you can follow this notification method. So we are going to discuss this notification method. So whatever we are doing right now, okay, this checking this manually, this method is known as pooling method. I'm pulling the status of TF0. Okay, so that method is known as pooling method. So if in question, if it is asked perform any program with pooling method, you have to follow this. And if it is asked with the other method, let's name the other method. Other method is known as interrupt method. Okay, so these two methods are there. One is pooling method, the other one is interrupt method. So we were performing pooling method while I write this, while tf0 equals 0. At that time I am performing this pooling method, but now we are going to perform an interrupt method throughout this session. So learn how to set up the interrupt method and how to use the interrupt. Okay, so basically what interrupt is in layman's language, for an example we have taken just before a few minutes, it is basically a notification kind of method. So you will be notified. Okay, rather than I'll say it interrupt, because what happens, you can ignore notification, but interrupt cannot be ignored. That's the difference between that two. Otherwise both are same. Okay, what we are doing, we are doing some other task, and I'll be getting updated about the event that has been occurred, like for which I was waiting. Okay, for example, in your case, we were waiting for a document. In case of timer, our desired delay is complete. That's the point where I wanted to be notified. For example, if I have designed a 1,000 microsecond delay, I wanted my timer to let me know once your 1,000 microseconds completes. Okay, so that 1,000th microsecond, at that point I'll be notified. Okay, rather I'll be interrupted, I'll say. So we are going to discuss about interrupt method and how to set up the interrupt method, and we'll see some programming based on interrupt method. Okay, so let's see that. So let's try to directly write a program. Okay, but before that, we already know what is an interrupt. We have discussed about this interrupt when we were discussing about 8085. Same way, in your 8051 you have interrupts. Okay, in your 8085, what was the name of the interrupt? The name was trap. Then there was your RST 7.5, 6.5, and 5.5. Other than that, that was one more that is known as INTR. Okay, so these are known as general purpose interrupts. Okay, and in 8051 as well, you have that kind of interrupt. For an example, INT1 and INT0. These two are the interrupt, but these are kind of hardware interrupt, so we are not discussing it right now. We are discussing about the timer interrupt right now. That means your timer can generate an interrupt. So why this interrupt are important? For an example, I have a program to generate 1000 microseconds. So rather than like wasting my time by writing this instruction while TF00, what I can do is I can do some other task meanwhile. Okay, and whenever this 1000 microsecond is completed, I can be interrupted by my 8051 timer. Who is going to interrupt you? Timer is going to interrupt you. Why? Because you are dealing with timer, right? Okay. So how to set up this interrupt? That's the first question. How to set up the interrupt and what happens whenever interrupt is there. So basically what happens whenever interrupt occurs, for an example, let's say I have this some random code. I'm going to write down some random lines here just to explain what it will do when interrupt occurs. So for an example, I can write here a is equal to b plus c, d is equal to e minus f, g is equal to I plus k, h equal to a minus b. Okay, I have this some kind of, this is my important code. Okay, I'm not going to say which code is this, but let us assume this is my code set of codes. Now my program counter would be here. Okay, it is executing this line. Then it will come to next line. It will execute d is equal to e minus f. It will come to next line. It will execute g is equal to I plus k or j plus k, whatever it is. Okay. So it is continuous executing. What will happen once this line is executed? It will go up again. Why? Because I'm in infinite loop, and it will start execution from a is equal to b plus c again. Okay. In background, what I have done is I want in background what I need is I need 1000 microsecond delay, and I have to toggle an LED with this 1000 microsecond delay. So what I need is 1000 microsecond delay. Okay, how to set up 1000 microsecond delay? We know that by having some TH and TL values, you can do 1000 microsecond delay. That's not a big task. Then what's the big task? The big task is to set up the interrupt method. Okay, so what I need is this. So what I can do is I will set up this 1000 microsecond delay. I'll let my timer run by writing this TR0. TR0 is equal to 1. I'll run my timer and then I'll execute this task. Okay, I'll continue this task. Meanwhile in the background, my timer is running. Like timer can run in background because it's separate module. So it can run in background. But when 1000 microsecond is done, like overflow occurs in your timer, at that time what will happen? Your timer will send an interrupt to 805. Okay, basically 8051 means it's CPU, or you can say it's timing control unit. It will send that I have an interrupt. So what will happen? Immediately, for an example, if I am executing this line, immediately I'll complete this execution of this line and I'll store which line is the next. I'll store the information of this. Okay, and my program counter will vector. Okay, this task is known as it will vector. It will vector to interrupt service routine. That's the name. That's how we call it. Interrupt service routine. So basically, what does that mean? Is it will go to execute task it should be doing. It should be doing which task in our case? In our case, it should be toggling LED. So it will go to toggle LED. That's the point. Okay. So you have to write this interrupt service routine. Then and that it can be done. Okay. So this storing this information where what's the next instruction and then vectoring to this interrupt service routine will done automatically. You do not have to bother about it. It will come here automatically. But what you have to bother is what should be written inside here. That's your business. You have to decide what we should write inside there. Okay. So now let's see an example. With an example, we'll see how to write an interrupt service routine and how your program execution will be done whenever there is interrupt on your controller. We are going to see that with an example. So let's first write a program, and we are going to write a program rather I have this program already. Let's say I'm going to perform this program. So we are going to perform the same program, write a C program to toggle LED connector to pin 1.3 with, let us say I'm changing this delay a little bit. Let's say not 1000 microsecond, but let us say 50,000 microsecond. Okay, I have just changed this information. I wanted 50,000 microsecond delay and I wanted to toggle an LED. Task case specify use timer 1 in method. Let us say it is specified like this. Okay, then you have to use the interrupt method. That's first point. Now, how to program your timer in interrupt method? So, like configuration would be same, number calculation would be same. The only different part would be you will not wait for your timer interrupt. Sorry, your timer overflow flag. You will not wait for timer interrupt overflow flag. Sorry, timer overflow flag. Okay, so this instruction, I'm going to modify this instruction. I'll highlight to where I have changed it. Okay. See, the line I'm going to modify, I'll highlight it. Okay, so let's say select timer which we want to use. So here I'm going to use timer 1. Okay, so I'm removing this part out. This is not important. No, you know how to do the things. Select mode of operation, select start method, select stop method. Okay, that can be decided using you. So no changes over there. Load timer according to required delay. No changes in that case. Also, okay. Then run timer. Okay, that's fine. We are not going to change anything here. Then we are going to change this step. Okay. So what I am going to do is I am going to strike through it. Here is the option of strike through. I'm not going to perform this task. Rather than that, what I'm going to do is instead of this file, let me change it a little bit so you can understand. Instead of waiting for timer overflow to set, what I'm going to do is here I'm going to set up for timer. Rather than waiting for your uh, overflow flag, what you will be doing is you will set up interrupt for timer. That's the one point which you will get change. Now always set it up before you run your timer. Okay, that's good practice. So always set up before you run your timer. Then and then you run your timer. Once you run your timer, what do you have to do? What do you have to do? You have to do nothing. You just run your timer. Okay, do your usual task whenever timer overflow, you will be redirected to ISR. What is ISR? ISR is interrupt service routine. That's the task. Okay, you will be automatically do your usual task, and whenever your whenever there is a you will be automatically taken to your interrupt service routine. Okay, so whenever you be taken there, like you taken back to ISR, what you have to do? You have to do this. Congratulations, you have generated desired delay. Do task you have to do after desired time delay. Okay, then what you have to do? If you are running in mode 1, if you are running in mode 1, in that case, what you have to do is you have to reload your timer. Okay. You do not have to clear your timer overflow flag. That's one more point. And you do not have to go to step 5. Okay. See, there are only these changes. So you are not going to modify any of this. Like calculation will be as it is, tmode, tcon, everything will be as it is. The only task that you will do new is set up interrupt. So you know how to set up interrupt, and then you have to do this task differently. This would be differently. Okay, you have to basically write an ISR. How to do this? You have to write ISR. Now, how to write ISR? That's also important. You must know how to write an ISR. Otherwise, you will be in trouble. So now let's check the same program. Okay. Almost program look like same. The only difference is here. Rather 1000 microsecond, I'm having 50,000 microsecond. Okay. So let's program for this 50,000 microsecond delay. So first step is you have to calculate your number. So I'll come here. I'll directly change wherever change is required. Okay, so I'm going to change here. I'm going to change here. Then we are not following 32-bit mode. That's why I want to do this. Remove the steps. Okay. Okay. So now what I'm going to do is I'm going to have the delay of 5,000. Sorry, 50,000 microsecond. So instead of this. So first, let's calculate the number. So instead of 5,000, I have 50,000. Okay, so that's 50,000. Here also 50,000. And if you calculate your number based on 50,000, what you will get is 50,000 steps. Okay, now we are not going to do this. Okay. Now, as your 50,000 is less than 65535, you can use 16-bit mode. That's the thing. Okay, so I'm going to program it based on 16-bit mode. So I'm going to calculate the number to be loaded in TCatch and TL. I'm going to calculate that number. How to calculate that? 65535. Why? Because it is 16-bit mode minus your number 50,000. So what you'll get is 15,535. Convert this to hex number. Okay, so I'm going to convert that to hex number using my calculator. I can say 15535, and that is 3CAF. So I have my number here. It is 0x3CAF. Okay, this part will be going to TL and the upper part will be going to TL. Now let's focus on program. So first step is first step here is to have that LED. Okay, I have done that. S-bit LED is equal to 0x93. Why 93? Because I have P1 P1.3. Okay, let's change it a little bit. Let's say P1.5. In that case, I have to go with 95. So 95. Okay, T mode equal to 00. No, now T mode would be what? T mode will be. So who will decide T mode? You will decide T mode. How you will be deciding T mode? So you will be deciding T mode based on the T mode register. Okay, so you must know what are the bits of T mode register. You have to mug it up. Okay, so what are the bits of T mode register? We know that bit is gate, then your C oblique T bar, your M1 oblique M0, again your gate, again your C oblique T bar, M1 and M0. Okay, now which timer I am using? This part is for timer 1. I have been instructed to use timer 1, so you have to use timer 1. Okay, this part is for timer 0. Which mode I have to select? So you have selected 16-bit. That's why you are going to operate your timer 1 in 16-bit mode. How to operate in 16-bit mode? 16-bit mode by writing 0 and 1 over here like this. Whether we are working with timer or counter, so we are using timer as a timer. That's why we'll get one more zero over here. Software start, hardware start. Nothing is specified, so I'll go with soft start. So this would be 0. I'm not using timer 0, so all the bits would be 0. So my number becomes 0x10. So let's write it down in this register 0x10. We have just calculated this number. It is 1C. What was 3CAF? Is that the number? Yeah, 3CAF. 3CAF. So I'll load 3C over here and AF over here. Now what's the next step? Next step is to set up the interrupt. Okay. So here I'm going to set up my interrupt. Before setting an interrupt, you must know how to set up the interrupt. Okay. So let's go there and check that how to set up an interrupt. So I'm going to open my data sheet and I'm going to interrupt section. Okay. See, this is the topic that we are going to study now. Interrupt priority structure and something related. One more topic would be there somewhere around here. It's not there. Okay, nothing to worry. So basically, to modify or to set or to reset or to have any interrupt. I'm not only discussing about timer interrupt, but any interrupt. You must come to your interrupt related register. Okay, which are that register? There are two registers related to interrupt service routine. And the first one is known as IE and the second one is known as IP. These are the two registers that you will be dealing with whenever you heard the word interrupt. Okay? So first register is IE and the second one is IP. Now what's the difference between these two registers? So as your TCON or T mode is timer SFR, same way your interrupt related SFR are IE and IP. Okay, so this is interrupt enable register and this one is interrupt priority register. Now I am not going to discuss about interrupt priority right now, so we'll left this without this, but I'm interested in the interrupt enable register. So using this register, basically using this register only, you can set up your interrupt. Okay, so for an example, you set up your notification in your mobile phone. So same setup is required here. How you are going to do setup? Using your register IE. You are going to change some bits of IE. So let's look inside IE register how it looks. So this is my IE register. Okay, I'm going to take it. See, this is my IE register. Okay. Now don't look at these two bits. We are not dealing with it right now. Okay, so just leave it a blank. For our course, these 2 bits are not important, but the other 5 are important. Okay, but from this 5, right now we are we will be dealing with 3. Okay, which 3? The first one is this EA and ET1 and ET0. So your interrupt enable bit for timer 0. This is my enable bit for timer 0. So if I want my timer 0 bit, timer 0 interrupt to be enabled, in that case what I'll do, I will write 1 at this place. Okay. Same way, if I want to disable it, to enable you have to write 1 and to disable you have to write 0. If I write 0, what will happen? The functionality of interrupt would be disabled. That means you are removing the notification setting in your phone. Even though mail received, no sound, no vibration, nothing will happen. Same way, if you write 0 at this place, particularly that place ET0, instead of that, if you write 0, what will happen? You won't be interrupted. You won't be interrupted. That means You won't be notified. Your program cannot go automatically to your interrupt service routine. That's the point. But if I enable it by writing one, your 8051 can automatically go to your interrupt service routine. It can automatically execute that program and it will automatically come back. So you do not have to worry about it if you have written one over there. Okay. Same way for timer one, this bit is there. This is a bit for timer one. So if I write one here, again, timer one interrupt service routine will be enabled, and if I write 0, it would be disabled. So if you are dealing with timer 0 and if you want your timer 0 interrupt to occur, what you have to do? You have to write 1 at this place. If you are dealing with your timer 1, in that case you have to write 1 at this place. That two are different places. Okay. So if you write 1 here, your interrupt should be working, but it won't work like that. Okay. Why? Because these 5 bits are known as local enablement. These are known as local bits. And there is one more bit here. This is a global enable bit. Okay. For an example, if you have a water tank, okay. An example, if you have a house like this, what do you have? You have a water tank somewhere on your house, on your terrace. And from there, you have a pipe coming all the way down to your sink. Let us say this is my sink here. So a water tap will be available here. Let us say this is a tap. Okay. And a water valve will be available over here. If I want a tank is full with water, okay. If I want water at the sink, what I should be doing? If I want a water, what should be I doing? Come on, response. You have one valve, you have one tap, full tank water. You want to wash your hands. How you are going to wash your hands? I need response. I have to pick someone. This is not going to work like this. Yes, Bhavesh. What will we doing? Bhavesh, please unmute yourself. Bhavesh.
I'm putting the bar.
I want is wait for a while. I want Bhavesh to unmute himself. Bhavesh, unmute yourself.
Yes, sir.
Yeah,
Yes, sir.
Bhavesh, what will be doing?
Open the
Open the
valve
valve
to
to
show the.
Okay, so basically what you will generally do is you open up this tap. Okay. But when water will flow from this tap, when water will flow from this tap, a condition is that if your valve is open, okay, that means both should be turned on. Then and then you will get water. What will happen if one is closed? If this is closed and this is open, no water flow here. Okay. Same way, if this one is closed but the main valve is open, no water in that case. So same way here, you have this global bit. It's like valve, and these are the local bits related to your local settings. Okay. So for an example, I can have a sink in kitchen, I can have a bathroom, I can have other like utility area where a water tap is there. So there are local taps. Okay, like this, they are local taps. If I want a water in my kitchen sink, what I have to do? I have to open up the kitchen sink tap. Same way, these are the local ones. If I want my timer 1 interrupt, I am going to turn on this bit. If I timer 0 interrupt, I am going to turn on this bit. But globally, there is a single valve which is going to control all this interrupt features. So if you want your interrupt to occur successfully, in that case you have to set up a global as well as local setting. Okay. Global setting is only one. By writing E is equal to 1, you can set up a globally, and in local you have different bit. For our example, it is 81. Okay. So what I'm going to do now is, as we are using timer 1, as you are using timer 1, what you have to do? You have to write a 1 over here and 1 over here. What should be other bits? Other bits should be 0 because we don't know what should, like, we are not using it. That's why we will make it off. Okay. So what I should write in my register IE? I should write 0x88. Okay. What this 88 will do? This will enable. This will enable timer 1 interrupt functionality. Okay, by writing IE is equal to 88, it will enable timer 1 interrupt functionality. Other than that, there is other method. Now this register is bit addressable. This register is bit addressable. So if you do not want to write it like this, the other option is you can write it like this: EA is equal to 1, and other than that, you have to make both this bit 1. Okay, so you have to write twice. In ET1 is equal to 1. Either way is correct. Okay, I follow this method because this is easy. You just have to directly remember that bit and you have to just write the bit. Here what might go wrong is, if, like, let us say we read it like this: 8421 8421, but if I'm in a hurry and if I read a 1 instead of here, so instead of 88 I will put 84. So this can go wrong, but this bits cannot go wrong, right? Because we know timer 1 is the E1 and E is the enable bit. Same way EA and ET. So it's very easy to remember. So this is how you can set up your interrupt. This is the way to set up my interrupt by writing two bits. One is global bit, that is known as EA. Okay, there is a particular name to that bit. I'm going to name that bit exactly in the document, like, as it is documented. But for our easygoing way, what we can say is a global bit and local timer bit, or you can say enable timer 1 bit. Okay. So let's see what's the exact name of this bit. Uh, okay, even they are showing it. They are saying it is global disable bit. If E equal to 0, all interrupt are disabled. If E equal to 1, each interrupt can be individually enabled or disabled by setting or clearing its enable bit. Okay, and then there are local bits like EX0, that is external. For an example, ET0, timer 0 interrupt enable bit. ET1, timer 1 interrupt enable bit. Okay. So these are the bits. So what we are going to do on our program, we are using timer 1. Okay, we are using timer 1. That's why I have to enable timer 1 interrupt bit. So I am going to write E is equal to 1, and other than that I am going to write ET0 equal to 1. So by writing this, what you have done, this is the wrong place. I'm editing it the wrong place, so I'll cut this out. Close this one. I'll say no, I don't want to save it. I have one more kale open somewhere here. I should be putting it over here. Okay. So this is my global interrupt bit. Not ET0, it should be ET1. Timer 1 interrupt enable. So I have set up my interrupt functionality. Now what I have to do? Now I have to do nothing. I just have to run my timer. Now as your timer start running, what will happen? Automatically at some point of time you will be notified that interrupt is there, and automatically 8051 will go to your interrupt service routine. So what you have to do now is you have to write interrupt service routine. How you are going to write interrupt service routine? So to write up your interrupt service routine, there is a special keyword. Okay, that there is a special keyword to write interrupt service routine. So how to write your interrupt service routine? So basically, to write this interrupt service routine, you have a special keyword. What is a special keyword? We know that special keyword for C is like let us say integer, character. That are all special keyword that means something to C language, C programming language. We are discussing about embedded C right now. So in embedded C, we have already two special keyword known as SFR, and the other one was S bit. We know these two keywords. Other than that, there is a third keyword a third special keyword, and that is interrupt. Okay, this is the name of keyword, interrupter. This is the spelling, INTERRUPT. There is a U inside there. This is the spelling, sorry, INTERRUPT. Okay, if you mess up the spelling, if you mess up with the spelling, you'll mess up with your program. That's why I'm saying this is the spelling. Okay, so this is the spelling of that interrupt, and this is how you write interrupt. So you are going to use this special keyword whenever you want to write your interrupt service routine. So to write the interrupt service routine, what you are going to do? You are going to use an interrupt keyword. This is a keyword that I'm going to use. Okay. Now let's see with an example how to write interrupt service routine. So basically, we are going to write an additional function other than void main. Okay. Now here, this part won't come here. Okay. So where it will go? It will go somewhere else. I'll show you where it will go and where it will go there. So I have removed everything from my main body. So my main task is free now. I can do anything with my main 805. But whenever your 1000 or 50,000 microsecond delay is completed, immediately your 8051 will come to your interrupt service routine. It will search for interrupt service routine. Let me show you. It will search for interrupt service routine. Okay. See, I'm going to run this code and I'll generate an error while running this code. See, you right now there is no error. Even though I have not written the interrupt service routine, then also there are no errors in my program right now. But as soon as I go to running the code, I generate an error. Okay, and how that error is generated? Okay, I'm running this code right now. See here, there is only one error, error 34, undefined identifier, and that's generating due to this. So I'm going to remove this. I can remove this error now. Let's check that. Yes, see, no error. Now I'm going to run this code, and now you can see here access violation at C0x01B no executed read permission. So basically what the error is saying you is that there is no interrupt service routine written for this program. So please write the interrupt service routine. Otherwise I am not able to execute the interrupt service routine. Okay. Now how to verify whether interrupt is generated or not? So let's check that how to verify whether interrupt is generated or not. Okay, so I'm going to reset this thing. I'm going to peripheral. This is my interrupt system, and other than that I'll have my timer 1. See what I'm going to do? I'm going to run this code. Now you can see your TH and TL is resetted, TF is not set, and here even here it is not set. Yeah, here it is set. Interrupt enable is there, and here you will see a request whenever your interrupt generates. Okay, I'm going to generate an interrupt right now by fooling the system. Now as soon as I go ahead with a single step, now the error is different. Just a moment, let me set up this thing. Yeah. Now I'm going to do FF over here. Now I'm going to single step. Again it is not visible. I have to reset it again. I wanted to show you the thing. It is not visible. Okay. FE. Okay, it's not I'm not able to show you that thing right now. I'll show it you later on. Okay. But the thing is, basically interrupt is generated and there are this error generated. Every time interrupt is generated and there is no ISR written, it will generate this error. So what I have to do, I have to basically write an ISR, interrupt service routine. Okay. So how to write an interrupt service routine? So it is written like a function. Okay. So basically you will start with void. Why we write void? Because we show that the no returns value is being passed to my main program. That's why we write void. Then I'm going to give a name. Okay. So let us say I am writing for timer 1. So I'll say timer 1 underscore ISR. This is the name. Okay. Instead of this, I can write anything. We'll say it. We can write anything over there. So void followed by a name followed by a blank bracket like this, and then here you have to write interrupt. This is my interrupt keyword. See, if you write wrong spelling, you will get it in black. Okay, right now it is in black, you can see. Okay, but if your spelling is correct, it will convert the color. Okay, you can see it is right now like maroon color of thing. So now this is how you write an interrupt. But now the thing is that you have to specify it is timer 1 interrupt. Okay, so this is not the way to specify. Let's change this. If you think this is the way to specify, let's change it to Jignesh. So name is Jignesh. Now how your 8051 will know whether I have written the interrupt service routine for timer 1 or timer 0. How to identify that? So along with interrupt keyword, you have to specify a number. Okay, and number is predefined. There are only 5 numbers that you can write, that is 0, 1, 2, 3, 4. If you write 0, it means something. If you write 1, it means it is timer 0 ISR. If you write number 3, then it means it is timer 1 ISR. So which ISR we have to write? We have to write timer 1 ISR because we are programming timer 1. So what we are going to write? We are going to write interrupt 3. Okay, and here I am going to toggle my LED. Now as this is a 16, like one, when it will come here, when your 50,000 microsecond delay is completed, it will come here automatically. When it comes automatically, what it will do? It will toggle LED. Other than that, as we are dealing with 16-bit mode, what you have to do? You have to reset your, reload your values. So you have to basically write this 2 lines again. Okay, so I'm going to do this task again, and then I'm going to complete. Now you might ask, sir, yesterday we have written TF0 equal to 1. Sorry, yesterday we have written TF1 equal to 0. So why we have written that? So we have written that thing because, see, if you read your timer instructions, yesterday we have read something related to interrupt there. Let me take back to you there. Okay, if you read here, the TF0, you'll read this thing. Timer 0 overflow flag set by hardware on timer counter overflow cleared by hardware. See, read this, cleared by hardware when processor vectors to interrupt routine. That means if you are following interrupt method for your timer, in that case your timer overflow flag will reset automatically or it will clear automatically. That means you do not have to write this line. You do not have to write this line. TF0 or TF1 equals 0. Sorry, equals. You do not have to clear it. That's the thing. Okay, so I'm not going to need this line. Okay. Now if I run this program, your delay would be generated as per the requirement. Okay, I'm going to run this code and let's see what happens. So I'm going to set up an LED. Okay. I'm going to close this thing and I'm going to run this program. You can see at the back end, you can see that waveform is going on. Okay, so it does not look like waveform, but it's correct waveform. You can see here the values are coming on. Now I'm going to add a breakpoint over here. Not here. I'm going to add a breakpoint over here. Okay. So each time your program runs like this. Okay, your time goes on, and then each time your interrupt will occur, it will come here automatically. Okay, I'm stopping it and I'm letting you know the time. What's the time? Time is 50 millisecond. You can see it's 50 millisecond. So even though your while one is blank, we have not written anything inside while one. Why we have not written anything here? Because we are following interrupt method. So what will happen in interrupt method? Whatever task written here will be executed. When your timer completes the time delay, it will notify you in terms of interrupt. Okay, so that's kind of notification method, and it will automatically come here to your interrupt service routine. How you are going to write interrupt service routine? By following interrupt keyword with a function. So this is my function body, like function name, and along with that you are going to write a special keyword that is known as interrupt, followed by a number. Which number you have to write? The number is decided by for what you are writing your ISR. Okay, there are 5 numbers, 0, 1, 2, 3 and 4. If you are planning for timer 0 interrupt like this, in that case you will write number 1. If you are writing your ISR for timer 1, I will write 3. Okay, so this is for ISR 1, that's why I write 3. Okay, now let's check one more time. I'm going to run this program. See, there would be no error here. Okay, see, can you see any errors? No, there are no errors. But I'll go back there. What I will do is I'll change this number. Even though I have this ready. Okay, let's change it to timer 0 number. That's 1. Okay, so even though I have written the interrupt service routine, it will generate an error. Okay, let's see. Access violation at C001B, no execution read permission. Why it has generated? Because you have not declared the interrupt service routine for timer 1. If you write timer interrupt 1 here, what does that mean? This interrupt service routine belongs to timer 0. So this is wrong. That's why it has generated an error. Okay. So this is how you program for your interrupt. Any questions? No questions is always good. At least I hope you watch this video 2, 3, 5, 10 times and understand what I'm going to say, like what I want to convey. The thing is, I don't know whether you understand or you do not understand. The other thing is you even don't reply, so how can I know? That's a big issue. Nothing to worry. I'll do my job, you do your job. But if you have any difficulty at any point of time, let me know. What I'm going to do now is I'm going to dump this code inside my controller, and I'll try to show you how it runs on laptop. Okay, so P1.5 is the pin. I have P1.45. I have fine, no issue. This can be done directly. Okay, again I'm going to turn on my video camera, and you'll be able to see on that. Okay, see, this is my hardware. Again, the same hardware that we were using. Now what I'm going to do is, again, I have to follow a boot sequence, so I'll press this boot button at the same time. I'll release boot button first, then I'll release this boot button last. First you have to depress reset, and then I'm going to connect. Okay, then you will open your software that is named as Flip. Open the Flip. Okay, I'm going to open my USB. Before that, you have to select the device, that is 88C5131. Okay, that's correct device. I'm going to USB open. So it's opened up. I'm going to load my hex file from here. Load trial project 3. This is the project that I'm working on since first day, so I know that this is the correct file. So I'm going to dump it. Okay, program is dumped. Now let's check. Okay, as soon as I press reset button, it will start. Now you won't be able to see anything. Can you able to see anything? Why you are not able to see anything? If anyone can answer, I'll be happy.
You need to reset it.
Yeah, I have reset.
And remove the USB and plug in again.
Okay, no issue. We'll do it. Something different is going on here. Okay, let me clearly tell you. Something very strange is going on here. Okay, I'll show you this experiment with the DSO. I don't have DSO right now. Okay, but I'll in next lab session I'll bring a DSO along with me, and I'll show you this is blinking. This thing is blinking, but the thing is that it is blinking at so high rate that you are not able to see it. In each 50 millisecond, it is turning on and turning off. And your camera rate, like even I am not able to see it here from the naked eye, and the camera rate FPS is generally at 30 FPS around. Okay, the video rate. So 30 frame per second is very slow rate compared to this toggling. That's why you are not able to see this. That's the first point. Okay, I'm going to slow it down somehow. Okay, I'm going to set it up to 1 second, and then we'll be able to see it. Okay, we are going to do a program for that. The next program is related to that. But before that, I hope you understand all this like whatever I have explained related to Intel. Same way, the same programming can be done with 13-bit mode, and same programming can be done with 8-bit mode. If you are using 8-bit mode, what will change? This number will change only. Okay, otherwise all this thing like you do not have to reload, so this part will be removed. So programming in 8-bit mode is given to you for a self practice. I have already uploaded all the experiment here. You can check that. Okay, so I have uploaded. All the assignments here. If you do not reply on time before due date, I'll get you straightforward 0. So keep that in mind. Deadlines are important and they are there for some reason. I'm going to show you which programs are there inside. There is a student view. Okay, so experiment 6 and 7 is basically related to timer. Even the next one, 8th one, is also related to timer. So here the first program is write a C program to toggle status of LED connected to pin 110 after 50 microseconds. We have just done that program. What's the difference? You have to follow polling method. Write C program, and even you have to show the output. Okay, so how you are going to show the output? You have to download the software key. I have shared the link. You have to run this code here. Whatever code you have prepared, run that code. Okay. Now that is called one. So practice yourself and run this code like this. Uh, put your two cursors like this. Take a screenshot of the screen and paste that screen in the output section. Then I'll come to know that you have performed the experiment by yourself. Okay. So this is the experiment number 6. Write a C program toggle LED connected to after each 50 microseconds. So this program will be with pooling method and this program will be with interrupt method. So same calculation in both the programs. So you do not have to calculate twice, just calculate for once and write the two program. Okay. Add the calculation before the program. Okay, calculation is not written over here, but you have to add the calculations. Then the third program, write a C program to generate square wave. This is a program which you have to think by yourself. Even in first internal exam, this program will be there. Okay, I'll let you know initially. This program will be there, like not with 20 kilos. Obviously, I'm going to change something in this program, but this kind of program will be exam. It will be in examination. You can discuss with me, no issue. I'll open to discussion. I can guide you how to generate this thing, but you have to think on your own. Come with something in your mind. Ask me. We will discuss in either next lecture, or you can even call me and we'll discuss how to get this program. It is very easy. Okay, it's very easy, let me tell you, but you have to just think how we are going to do this thing. Okay, and there is one more program which is related to PWM signal. I won't ask this in examination. Okay, let me clear it. First internal. Okay, we can do it. We have a lecture tomorrow. Okay, then no issue. I'll explain you this two program tomorrow. I'll show it with the DSO as well, like in DSO, in CR or DSO, I'll show you the waveform that we have generated. So this two program are on me. Do not worry about that. Let's go to the other experiment. This is related to mode 2. We have seen that. Experiment number 7. So here mode 1 related programming are there. 50 Hz square wave. You can do it once you know how to generate 20 kilohertz. Toggle 50 millisecond, easy. And there is this program that we are going to do right now. Write a C program to toggle LED after each 1 second. What is the maximum possible delay using your 8051 timer? Can anyone answer? Can anyone answer what's the maximum time delay? What's the maximum time delay? With my timer of 8051, even though if I use it in 16-bit mode, what's the maximum time delay that I can generate? Okay, No issue. If you don't know it,
6553
555 microseconds. Correct. The thing is, now I'm going to change something. The first thing that I'm going to change is frequency. See, this board has this inbuilt crystal over here. I have already shown you this one. And this crystal is of 24 megahertz. So you cannot calculate based on 12 megahertz. 12 megahertz calculation will be wrong. So whenever you are doing on this board, you have to consider a frequency to be 24 megahertz. Which frequency? Crystal frequency. Okay. So we'll start with F crystal to be, sorry, I'm going to write a program, LED. Okay, LED toggling at 1 second. That's my target. Maximum delay with 24 megahertz would be half of 65 microseconds. Like it was somewhere around 30 microseconds. Okay, but we are not going into that. Okay, let's see how to do this 1 second program. How you can trick your 8051 for other tasks. So what I'm going to do, I'll first calculate the number. So 24 megahertz is my frequency of crystal. So F crystal is 24 megahertz. So my F timer would be not 0.2 megahertz, and my T timer would be 0.5 microsecond. If you don't believe me, you can calculate it. You will get these values only. Number of steps required. How to calculate that? We know that for 0.5 microsecond, you require one step. What about 1 second? So what you will get is 1 second divided by 0.5 into 10 to 6. So 1 upon 0.5 is 1 upon 0.5 is what you will get? 2. 2, correct. 2 into, sorry, this would be minus 6. 2 into 10 to 6 steps. Okay. Now, is it possible to have this number of steps with any mode? Whether you use 16-bit, 13-bit, it is not possible. Okay. We know that this is not possible. This is like huge number. Okay. If I write that number, it looks like this. 1, 2, 3, 4, 5, 6. And your number, maximum number is only this. So it is not at all possible. It looks like that. But what I can do is, I hope your screen is visible. Let me share it one more time. I hope my screen is visible.
Yes, screen is visible.
Yeah, visible.
Okay, so what we are going to do is we need this number. I can go up to this number only. So what I'll do, I will run my timer for somewhere near to this number. Let us say this number. I will run my timer for 50,000. And what I'll do, I'll run it for 20 times. In that case, what I'll get? Let us say 40 times. 5 into 4 is 20. 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. So if I run the timer with 50,000 inside there for 40 times, okay, what I'm going to do, I'm going to generate a delay of this number, 50,000, whatever is the delay. Okay, if it is a 12 megahertz, it would be 50 microsecond, but right now we are dealing with 24 megahertz. That means it's only 25,100 microsecond delay. But we are not going into that. We need this number. This is the number that we need. So what I'm going to do, I'm going to trick my 8051 and I'm going to run my timer for 25, not for, with 5,000 steps for 40 times. In that case, I can reach up to that number. Yes or no? If I take 50,000 steps 40 times, I can reach there, no issue. Okay, so what I'm going to program for, I'm going to program for this and then I'm going to run that 40 times. So how to do that? So first let's calculate the number. So as this number is 50,000, I know the number would be 3C here. We have just calculated. So I'm going to modify the program wherever modification is needed. I'm going to modify this program only. I'm not going to write a new program. So 3CF mode 1, timer 1 I am using in mode 1. 3CF, okay, this delay is correct. For 50,000, this number is correct. Okay, so it will generate it. And when 50,000 is completed, it will come here. Now what I want to do, I wanted it to run for 40 times. So what I can do is, I can check by using one counter, additional counter I can use. Using that counter, I can check whether it has done it 40 times or not. Okay. So each time it comes here, I'll increment that counter. So I can have a counter named as I. So I is equal to I plus 1. Okay. So I start with I equal to 0 in main body. Okay. So initially my I will be 0. Then I can increment I by 1. Each time overflow occurs, it will come here. I will increment I. So when you have like your timer runs for 40, then what will happen? I will reach 40. So now I can check if I is 40, then I have to take a decision. If I is 40, then what I have to do? I have to toggle LED. So I can toggle LED. This is the only modification that is needed. I am going to declare I because I have used I and unsigned character I. No errors. Control F5. I'm going to run this code and I'm going to run this code, but with and okay. See, I'm going to run this code. So you can see your value of I is incrementing. Let me see. So I is 0.5 right now. Okay. Each time I press this button, it will increment it. I have to remove this. Yeah. 17, 19, 1A, 1B, 1C, 1D, 1F. This is 32. 1F is 32. Okay. Then 33, 4, 5, 6, 7, 8, 9, 40. Now, if you go inside there, okay, still it is not 40. Now it is 40. See, your LED will toggle now. What I have done, I have tricked in. See, your LED is toggled. So from here to here, if you measure the time, it would be almost 2 seconds. Why 2 seconds is showing it? There is an because internal frequency is 12 megahertz here. So I'll change it to 24. And I'm going to run it again. Now I'll remove these two breakpoints. It went there. And I'm going to run this code. So you can see this toggling is there. But if you look at this, your time will be wrong. See, it's 8 seconds. So why time is wrong? Time is wrong because first time, as soon as your I reach 40, what you have to do? You have to start again with 0. So you are not starting again with 0. So you have to start it again with 0 by writing 0 over here. What is happening? Your 40 count is there. Your LED is toggling for once. Then again, I will start from which number? 41. So if I is not 41, it won't pass 41, 42. It will go up to 255 and it won't execute any of the instruction. Again, it will become 0 and again it will become 40. Then it will execute this. Okay. So what I'm going to do, whenever it comes to 40, I'll reset it by writing this instruction. Now if I run this code, you will see. And if you look at this delay between that two is 1.31, somewhere around 1.32. Okay. 1.32. Why it has occurred? Why it has occurred? Anyone can answer? Because we have not reloaded the number here. TH and TL should be reloaded. You have not done it. That's why it is getting me the wrong answer. So I'm going to paste this few line of code here. Every time you have to run for 50,000 only. Okay, but if I don't reload, it will run for 65,000. So modify it, run it again. And now if you look at this delay, it would be 1.00908 second. And if you dump this code on that board, you will get the correct delay. I'm going to show you the board and I'm going to dump that code. Okay, first detach, press board button. attach, go to your flip. Where is flip? Select your IC, that's correct IC. Open your USB. Could not open, that means there is an error. Again, I am going to put the button. Use this one, and then attach. Then this should be open. Yeah. I'm going to dump the new code that I have just prepared, and I'm going to run the application. Okay, done. Now, as soon as I press this reset button, you will see the LED blinking. And the rate is almost 1 second. You can check it. Are you able to see that?
Yes.
So it is blinking at 1 second rate. Are you believing it or not? At least it is visible now. I hope.
It's visible.
Yeah. Okay. So this is how you can program for a different time delay. I can have 1 minute delay as well on this thing. Okay, I can have that. No issue. See, I am going to show you quickly. Let's increase this delay to 10 times. Okay. So rather than 40, I should have 400 here. So 1 second, 10 times. So 400 should be the correct number. And instead of character, now I should use integer because 400 is large number. And I'm going to run this code again. Now you can see this time is 10 seconds. 9.99 seconds. Okay. I'm going to dump this code again inside the board and I'm going to show you. Yeah, okay, I'll start this application. Yeah, I have pressed wrong button. It goes off. That will come on after 10 seconds. Okay. See, this is how you can program your 8051 timer. That's how you can do it for the larger timer delay as well. So your timer is very important and we have seen how to use it with pooling method or interrupt method, whichever you prefer. I hope you understand this concept. Okay, just this is a simple maths. I'm doing nothing else here. This simple maths. Okay. So just look at the video one or more times and you will be able to understand what I want to convey if you are not able to understand that. Okay. Any questions?